Hello, welcome back to another Anarculus production about limits. Today, we are going to talk about infinite limits. So let's start with something that you already know how to do and that you're already well aware of. Let's talk about what is a vertical asymptote. Let's talk about what a vertical asymptote is. So you certainly know what a vertical asymptote is graphically. Everybody can draw it. I know that. So if I put a value, let's say C, here's my vertical asymptote. And then if I were going to draw my graph, I could draw whatever function that I wanted to. However, the graph cannot cross this vertical line, right? That's what a vertical asymptote means graphically. It means that it's a line, a vertical line that the graph will not cross. But if we be a little bit more specific about what that graph might look like, there's really only a couple of things that graph can do around the asymptote. So if my graph is moving in this direction, let's say, well, then as it gets closer to the asymptote, the graph has to go up like that. Okay, you can't cross this line. It'll just keep moving up forever. On the other side of the graph, well, it could do a couple of things. Certainly, it could, start here and then work its way down like this, right? That's certainly possible. Okay, it could even work its way up. All right, but again, it's a line that it cannot cross. But if you notice, this vertical asymptote, if we talk about this as being our function f of x, it actually leads us to a definition of a vertical asymptote that you've never really seen or talked about. Okay, that definition is as follows: the line x equals c is a vertical asymptote of f of x if the limit as x approaches c from either the right or the left of f of x is equal to positive or negative infinity. Okay, and you can see that definition being played out right here on our graph. As x approaches c from the left, this graph goes straight up to positive infinity. As x approaches c from the right, this graph goes straight down to negative infinity. Now, again, we can change the graph slightly if we wanted to, right? I mean, we could make this piece here, or the second branch, approach positive infinity as well, because the definition doesn't say which it has to approach. It just says it has to approach one of them from the right or from the left. That makes the line x equals c a vertical asymptote, because the graph is forced to go straight up or forced to come straight down. So the graph can never actually cross that asymptote. So that is a definition of a vertical asymptote that we will use during the school year. Okay, so today what we're going to talk about actually is we're going to talk about infinite limits. All right, so let's take a look at an example here, something that's simple. We'll start with something simple. Let's try the limit as x approaches 0 of 1 over x. It's a pretty simple function to work with. So the first thing I would obviously do is try direct substitution. The limit as x goes to 0 of 1 is 1. The limit as x goes to 0 of x is 0. I get 1 over 0. Now, 1 over 0 is a commonly mistaken limit. Okay? 1 over 0 does not mean undefined. It also does not necessarily mean does not exist. So let's talk a little bit about the difference between the two of those right off the bat. If I were to give you a function, f of x is equal to 1 over x, and I were to ask you to calculate in Algebra 1 or Algebra 2 f of 0, you would take 0, substitute it in, you get 1 over 0, and you would tell me that's undefined. You cannot have 0 in the denominator. And that is absolutely correct. Okay, that is an absolutely correct answer. All right. But here, I'm not asking you for where you are standing, right? You can't stand on 0 here because x equals 0 is a vertical asymptote, right? It's a non-removable discontinuity. Okay, 1 over 0, non-removable discontinuity. So f of 0 is undefined. You can't stand on x equals 0. There's no y value to stand on. However, I'm not asking you to stand on there. I'm asking you what the limit is, where you are walking toward. So the question is it possible to figure out what value you are approaching as x approaches 0 of 1 over x? And the answer to that is yes. So the question is, how do you do that? Well, like anything, if I want you to calculate the limit as x goes to 0 and I don't tell you which direction to come from, the only way to do it in this case is to calculate the limit from both directions. So let's try the limit as x goes to 0 from the left, and then we'll have to try the limit as x approaches 0 from the right. All right, so now let's talk about what we get. The limit as x goes to 0 from the left of 1 over x. In the numerator, I get 1. In the denominator, what am I doing? That's what I need to understand, is what is actually happening with the graph, okay? Or what is happening numerically? Well, I'm at, let me put it here. So here's 0 on my number line. If I approach 0 from the left, I'm approaching from this direction, right? Numbers that are just smaller than 0, but they are also considered to be negative, right? So these are negative numbers on my number line, okay, on this side. And as I get closer to 0, these numbers are negative numbers, but they're awfully small and awfully close to 0. So they're like numbers such as negative 0.1, negative 0.001, negative 0.00001, right? So they're negative and they're very small. So what I actually have here in terms of a limit is I have a negative number that is extremely small. So let me just write it like that for now, okay? So now the question is, where does that go? Well, what does it mean to be 1 over a number that's really small? All right, well, we're going to have to figure that out, okay? And the numbers are getting smaller, right? The numbers are not just small, they're getting smaller, okay? And really close to 0. So negative 0.00000000000000001, okay? Really small. All right, let's talk about what it means to be a constant value over a number that's really small. So let's come over here for a second, just as an aside, and we'll talk about what that means. Let's take a number such as 12. Okay, there's a constant. And now I want to take 12 and divide by 12. You'd get 1. If I take 12 and divide by 6, you'd get 2. If I take 12 and divide by 4, you'd get 3. 12 over 3 is 4. 12 over 2 is 6. 12 over 1 is 12. Okay, let me come up here. What's 12 over a half? Well, keep this, change this to multiplication, and flip this over. So that becomes 12 times 2 over 1, which is 24. What's 12 over 1/3? So you can get the idea. You can see what's happening. So this is 12 times 3. That's 36. As the number in the denominator gets smaller, the result gets larger, right? 1, 2, 3, 4, 6, 12, 24, 36. So as this number gets smaller and smaller and smaller, the overall result gets larger and larger and larger. But how large will it get? Well, how close can we get to 0? Really close to 0, which means that this 1 over something that's really small could be something that's really big. So this value could go to infinity. Okay, or it looks like it's going to go to infinity. Now, which infinity? Is it positive or negative? Well, look at the signs. You have a positive 1 and a negative number in the denominator. Positive divided by a negative is a negative. This goes to negative infinity. Okay, that's where your result goes from the left. Now, from the right, as x goes to 1 from the right, if you come in this direction, okay, you're talking about numbers that are just larger than 0. So it's 1 divided by, again, the numbers are really small because they're really close to 0, but they're positive, right? Because they're coming from this direction, from the right, meaning the right side of the number line, meaning they're just larger than 0. So now I have 1 over a number that's really small. Well, the result's going to be really large, infinity. A positive divided by a positive is a positive. So this limit goes to positive infinity. Now, the question back on the table is, what is the limit as x goes to 0 of 1 over x? Well, from the left, I go to negative infinity. From the right, I go to positive infinity. So the limit as x goes to 0 does not exist, because from the left and from the right, I don't go to the same place. Okay? You can see it graphically as well, what this graph looks like. All right, it's not very complicated to draw. So here is your asymptote. So your graph looks like this. Here's f of x. This is 1 over x. Okay, so from the left, you're going down to negative infinity. From the right, you're going up to positive infinity. So the limit does not exist from the left to the right. You don't go to the same place. Now, this is the numerical analysis that you can do so that you don't have to make a graph. Because we don't want to make a graph for everything, right? I mean, you want to do some kind of numerical analysis because that makes life a lot easier. Okay, so the limit here, it is true that the limit does not exist. Okay, f of 0 is undefined. In this case, the limit does not exist. All right. So let's try another one. I'll show you another way to write your answer in terms of writing like negative small, positive small instead of doing that. So let's take the limit as x goes to 0 of 1 over x squared. Okay, so now that's slightly different. The limit as x goes to 0 of 1 is 1. The limit as x goes to 0 of x squared is 0. This is 1 over 0. All right, so the question is, what is 1 over 0? Well, it's not 0 over 0. It's not indeterminate. Okay, 1 over 0 is going to be a limit that's either going to go to positive infinity, negative infinity, or the limit will not exist. Okay, those are your only 3 choices. You're going to go to positive infinity, negative infinity, or the limit doesn't exist. Because x equals 0 is an asymptote, right? It's a vertical asymptote. So at the vertical asymptote, the only place that the graph can go is up, down, or if it goes up on one side, down on the other, the limit doesn't exist. All right, so we're going to have to try from both sides then to figure out where it goes. So let's try from the left, and then we'll try again from the right. All right, so let's try the limit as x goes to 0 from the left. From the left, okay, in the numerator, I'm going to get 1. In the denominator, well, if I look at my number line, here's 0. From the left, I'm approaching 0 from the left. So these numbers are negative. Okay, they're negative, they're really small. Okay, negative and really small. But when I take these negative small numbers and square them, it gives me a positive number, right? Negative times a negative is a positive. So this gives me a positive number that's really small. Okay, positive number that's really small. So what some people do is instead of writing a positive small number, they write this, and this is, I will accept this, they write this, positive 0, okay? So that's okay. And now 1 over something really small is something really big. Positive divided by positive is a positive, so that value goes to positive infinity, where this limit approaches positive infinity. The limit as x goes to 0 from the right of 1 over x squared. Come in from the right, you're just larger than 0. So in the denominator, you're going to get 1 over something positive, square it, you still get something positive, but the number is going to be really small, or 1 over positive 0, which is positive infinity. Positive divided by positive is positive. 1 over something really small is really big. So this limit as x goes to 0 of 1 over x squared, we would write it goes to positive infinity, and that would give you credit for your answer. That is the correct answer. Okay? Do not write DNE just because you get 1 over 0. Not write DNE just because you get 1 over 0. That does not mean necessarily that the limit, we should write the limit does not exist. All right? Because the limit goes to the same place in both directions, we'd have to describe where it goes. Okay, let's try another one. Let's try the limit as x goes to 2. Let's say from the right of x minus 5 over x minus 2. Okay, so if I plug in 2, I try to use direct substitution. The limit as x goes to 2 from the right of 5, or 2 minus 5 is negative 3. In the denominator, 2 minus 2 is 0. So the question about negative 3 over 0, it's not indeterminate. 2 is a vertical asymptote. The question is, does it move positive infinity, negative infinity, or does the limit simply not exist? That's the question on the table. Now, we're only approaching from one side. Okay, so that should give you a hint. If you're only approaching from one side, you should automatically be able to eliminate one of these three choices. One of them can't possibly be the answer. All right, one of them can't possibly be the answer that you would write down. So think about that. Okay, so if x approaches 2 from the right, if I substitute 2 in the numerator, I get -3. If I substitute 2 in the denominator, 2 from the right is just larger than 2. Okay, so it's like 2.1, 2.01, 2.001. If I take those numbers and plug them in or direct substitute them into the bottom, I get a number that's really small, but the number is positive because it's 2.01 minus 2, which is going to be a positive number. Okay, or -3 over a positive 0. So negative divided by a positive is a negative. 3 over something really small is really big. This result is -infinity. That's where the limit approaches. Okay, that's where my limit approaches. All right, let's try another one. Let's try the limit as x approaches 1 from the left of x minus 1 over x minus 1. So if I directly substitute 1 in here without using the limit laws, okay, now I could use the limit laws, and I'll show you how to do it in a minute. If I directly substitute it in, I get 1 minus 1 over 0. All right, so the question is, what am I going to do with this? Well, first of all, this 1, what gets done with that? Now, the limit laws, what it allows me to do, obviously, is to separate the two. So I could write the limit as x goes to 1 from the left of x minus the limit as x goes to 1 from the left of 1 over x minus 1, and calculate each one of them separately. This limit is 1. Minus, I'd have to calculate this limit. Okay? The second limit gives me 1 over 0. So it gives me 1 over 0. It's either going to positive infinity, negative infinity, or the limit doesn't exist. I have to figure out which one. So if I come up here, here's 1. 1 from the left is this direction. So this is numbers like 0.9, 0.99, 0.999, just smaller than 1. If I take that, substitute it in up here, I'm going to have 1 over 0.9, 0.99, 0.999. Well, it's going to be a really small number, and it's going to be negative, right? 0.9 minus 1 is going to be a negative. So this is a positive divided by a negative. That's a negative. 1 over something really small is really big. The result goes to -infinity. So now this limit goes to -infinity. So now I have 1 minus -infinity. So that's really 1 plus infinity if I clean it up. So now the question is, what does the 1 do to this infinity? Right? What is 1 plus infinity? Well, the infinity just laughs at the 1. It says, okay, well, add 1 more to my infinite amount, and you get an infinite amount. This approaches positive infinity. This limit goes to positive infinity. And that's the correct answer. Okay? All right. Let's try, we'll do 2 more. Let's try the limit as x approaches 2 from the left of x over x squared minus 4. Okay? X over x squared minus 4. Now, if I take 2 and try to directly substitute it, I get 2 over 2 squared is 4. 4 minus 4 is 0. So the question is, where does this go? Positive infinity, negative infinity, or does the limit simply not exist? Again, one of these can't possibly be the answer because I'm approaching only from the left. So there's no way, hopefully you figured it out by now, what it is that I'm trying to get at. I'm obviously trying to get at the fact that the answer here can't be DNE, because DNE you would write when the limit from both sides goes to a different place. But you're only approaching from one side. So the answer either has to be positive infinity or negative infinity. All right, those are your only choices at this point. So if I take 2, put it in, 2 from the left is just smaller than 2. So that's like 1.9, 1.99, 1.999. If I plug or substitute 2 in the numerator, I get 2. Underneath, got to do a little analysis. 1.9, 1.99, 1.999. Take that number, square it, and compare it to 4. Okay, so 1.999 squared is not quite 2 squared. So this number is going to be smaller than 4. It's going to be 3.99999 minus 4. So that's going to be a negative number, and it's going to be really small. So 2, positive 2 over a negative number is a negative. 2 over something really small is really big. So the result is negative infinity. Okay, so some of these are not necessarily obvious. You got to do a little analysis to try to figure out what happens to them. All right, you got to do a little analysis to figure out what happens to them. And again, why are we getting all these infinities, infinite answers here? 2 over 0. Okay, x equals 2 is a vertical asymptote. It's a non-removable discontinuity. If I take 2 and substitute it in the denominator, 2 over 0, and I were to ask you what f of 2 was, you'd say it's undefined. Okay, there's a non-removable discontinuity there because the denominator comes out to be 0. So x equals 2 is a vertical asymptote. Here's x equals 2. Here's my graph now. See that? Ta-da. Okay, here's my graph. What's going to happen from the left? Well, it's either got to go up toward 2, it's got to go down toward 2. So in this case, it's going down to negative infinity. Okay, that's because there's a vertical asymptote there. That's what's forcing this to happen. All right, so we'll just try one more. Let's try the limit as x approaches 5 of x squared minus 25 over x squared minus 10x plus 25. Okay, so if I take the limit as x goes to 5, and let's try to substitute it in. 5 squared is 25, 25 minus 25 is 0. And then in the denominator, 5 squared is 25 minus 50 plus 25. 25 and 25 is 50. 50 minus 50 is 0. This is 0 over 0. This is indeterminate. Okay, this is an indeterminate form. So now the question is, what do I do with an indeterminate form? We already learned what to do with an indeterminate form. You try to figure out what would an Algebra 1 kid do. So an Algebra 1 kid would just factor the top and factor the bottom. So they factor x minus 5 times x plus 5. The denominator is x minus 5 times x minus 5. Right? These cross out. That's good. That's what I wanted. Okay, there had to be an x minus 5 in the numerator and an x minus 5 in the denominator. That's what was giving me 0 over 0. And now I just want to calculate the limit as x goes to 5 of x plus 5 over x minus 5. So now if I take 5 and I substitute it in the numerator, I get 10. If I take 5 and substitute it in the denominator, I get 0. This is 10 over 0. So now this limit is either going to go to positive infinity, negative infinity, or the limit's not going to exist. Okay, 10 over 0. That means 5 is actually a vertical asymptote. So now, how do we do that? Well, we need to try from both the left and from the right because it doesn't tell us which side to approach from. So we'd have to try the limit as x goes to 5 from the left of x plus 5 over x minus 5. Well, if I plug in 5 to the numerator, I get 10. Into the denominator, to the left of 5 is like 4.9. So that's going to be a negative number in the denominator, but the number is going to be really small. Positive over negative is a negative. 10 over something really small is really big. The result is negative infinity. The limit as x goes to 5 from the right, okay, is of x plus 5 over x minus 5 is 10 over 5 from the right, just larger than 5. So like 5.01 minus 5 is going to be a positive number, really small. 10 positive over positive is positive. 10 over something really small, something really big. This goes to positive infinity. From the left, I go to negative infinity. From the right, I go to positive infinity, which means that my limit as x goes to 5 of x squared minus 25 over x squared minus 10x plus 25, this limit does not exist because from the left and from the right, I don't go to the same place. Okay? So there was an example where you used what we already learned with an indeterminate form of 0 over 0 with an additional application of getting a numeric value other than 0 over 0, right? And then you had to check to which large result it went to, positive or negative infinity. And in this case, you had to try for both sides. Okay? All right, so that should be enough for you to understand that one. Okay, and as always, thanks for clicking.